Well, good afternoon or morning, depending on where you are in the world today. Welcome to the second installment of our webinar series, Beyond the Scan, Real-World Applications for 3D Body Data. In this series, we'll be exploring ways innovative companies and organizations are utilizing 3D body scanning to transform the apparel, health, and fitness industries. Just a quick note on flow. If you have any questions that you want to ask, please feel free to post them in the Zoom desktop. There's a question and answer section, and we'll be holding the last 10 minutes for questions and answers with our guest speaker today. For those of you who do not know your host today, we are Sizestream. My name is Jeff Messer. I'm head of sales and marketing here at Sizestream. We are a company that produces body scanning software and solutions. And we are based in Raleigh, North Carolina, with sales and support offices in London, Bangalore, and Hong Kong. We have over 20 years of experience in bringing 3D body scanning solutions to market, and we strive to be the thought leader in our industry by bringing relevant and insightful content about 3D body scanning. So our topic today, excuse me, I was not advancing slides, which apparently I can't do. So Ryan, if you will, oh, there we go. Okay, so that's us, that's Sizestream. Sorry about that, guys. A bit of a slow start here. Our topic today, body scanning, bringing clothing future forward. We'll be talking with one leading university who is incorporating 3D body scanning into course curriculum and teaching the next generation of product designers to start with 3D. And on that note, Dr. Simeon Gill is our guest speaker today. Simeon is a senior lecturer in the fashion industry and focusing his research on, whoops, we went one too far. Can we go back, please? There we go. Senior lecturer in the fashion industry, focusing his research on technology, working with 3D body scanning and the automation of block pattern construction. Simeon conducts ongoing research in sizing, body scanning, pattern drafting practices while continuing to explore how technology can help create better automation and block developments for garments that better reflect the needs of the wearer, which is a key point we'll be talking about today. So with that long introduction, Simeon, let me go ahead and ask you to take the mic. And of course, this will be a dialogue. It won't just be Simeon talking to you for the next 30 or 40 minutes. It'll be a dialogue between he and I. And again, just a reminder, if you have any questions that come up during the discussion today, please feel free to enter them into the Q&A board below. Simeon, welcome.
Hi. Jeff, thank you for the introduction, and I'm delighted to have the opportunity to speak to everybody about what we've been doing with body scanning technology. I need to move, I think, to the next slide. Is that right? But I've lost the controls I had, so I'm afraid I'm kind of at the mercy of you advancing me.
Well, technology is great when it works, right?
All right, lovely. Yeah, I just have exactly what you all see now.
Yeah.
So I'm missing from that, but it's fine. I know roughly what I was going to talk about on each slide. So obviously, I'm an academic, a senior lecturer at the University of Manchester, and I've been dealing with body scanning technology for a number of years. About 15 years we've been involved in body scanning research. I don't research on my own. I'm part of the team. I'm currently part of the Apparel Design Engineering Research Cooperative based at the University of Manchester, and there's myself, Steve Hayes, Christina Bruback, and Chris Parker. And we've done quite a lot of work together more recently looking at how scanning can be used in an academic environment. We also do things for industry. We've looked at plus size scanning for industry and how scans might be used to help inform sort of practices in industry themselves and help people understand sort of how body scanning can engage with industry practitioners. But one of the main uses we have as well is sort of how we can use scanning in an academic setting so we can inform new students and new people entering into industry with the benefits of this technology and what it can do. So I think at this point, if we move to the next slide, I'm sort of struggling a little bit without my notes. I probably should have printed them. But again, I think I'm going to talk around most of what I had anyway. So really, body scanning, there are a lot of benefits to using body scanning, whatever scanner you happen to use. Currently, we're running a Sizestreams scanner, and we're finding a lot of benefits in it. But if we look at it, there are three main benefits that come to the fore for us. So it provides details of specific consumers. So creates a greater depth of data to drive the product. So when we're looking at what do we want to develop, how do we understand the customer base we might have or the population we might be using, scanning provides a great opportunity to start to do that. It removes the need to guess or predict data during pattern development. So if you conduct research or are involved in generating patterns, and patterns are the first step of creating garments, what you'll notice within any of the processes of making and drafting garments, there's a lot of prediction, okay? So there's a lot of things where if you know the bust, the waist is this calculation, or you know, maybe the bust position is halfway down, or side depth is a set amount. And when you have the scanner and the facility to draw on lots of data from the body and even investigate it in innovative ways, you don't need to guess data anymore. You don't need to fall back on the proportional relationships that are implicit within pattern making. Or pattern cutting itself. You can draft patterns using the body. And that's something I'll touch upon in later slides in much more detail. But also scanning allows an insight into the body, its appearance, its shape, its size, and its proportion. So one of the things we've been able to do with scanning is provide a way to have a discussion with people. You can stand and look at someone and talk to them about their body. You can make a judgment about their body. But when you've physically got their body as a 3D visual on screen in front of you, you can spin it around and look at it and discuss it in a great deal of detail with them. As I say, we've used scanning in product development, and this relates to some of the research that we've been doing here. And obviously I did some research more recently with Ellen McKinney from Iowa State University. We're looking at trouser block development. And you can see here on the right-hand side, there are cross-sectional scan slices from scans of dress forms. And you can see the difference in the shape of the crotch curvature and the depths of those bodies. So we've been able to use body scanning technology to get information that you wouldn't typically have using traditional manual tools. And you can really innovate the way you approach the development of things. So this was looking at crotch extension, or what in the UK we call fork quantity, which is a depth of trousers through the body. And at the moment, in pattern making methods, in the drafting of patterns, it's a calculation. You use hip circumference to determine crotch depth. But when using scanning technology, we don't need to predict it, right? We can physically take this measurement, but we can also start to look at what the curves are of the body and how they might inform it. So scanning allows us the opportunity to get data that would have historically been incredibly difficult to get. And I think that's something that probably Sizestream hear from their consumers, Jeff, in terms of people saying, well, I can get data that I couldn't get. And some of this might reach you in terms of demands for information from the scanner that you often might not think about having in traditional guidance for scanning applications.
Yeah, very much so. In fact, one of the, I would say, newer additions to the team at Sizestream is actually a group of dedicated individuals who are helping develop made-to-measure garments for customers, and we've done some experiments of our own in kind of a user experience type store. We'll call it an experience store, and the ability to identify shape coming out of those scans is hugely beneficial as we look at developing blocks and patterns for made-to-measure garments. You know, the distribution of proportions from the seat, for example, talking about trousers, from the seat to the front of the torso, you know, allows you to look at, you know, creating that, or I should say, fixing that problem of the diaper bottom pants, right? Is that it's a big benefit to us in getting both accurate measurements as well as that shape silhouette, so that the pattern designers or the technical designers can do a better job of designing garments that will actually flatter the wearer's body.
Right, absolutely. And again, you know, you touched upon that ability to get information you wouldn't typically get. I mean, the ISOs don't tell you to take depth. The pattern construction literature doesn't tell you it needs depth. But when you have depth, you can start to approach patterns in a different way. And the scanning can really flip how you understand body to garment relationships. So we can just move to the next slide, which sort of expands upon this a little bit more. But you can develop new methods for creating patterns. So more data is useful, and you can define depths and positions on the pattern, which will help in creating suitable shapes. So one of the things we've noticed, we can get this depth, and we can start to use what I'll term as Z depths, because in essence, that's what they are. They're the dimensions in space as a Z depth from a central location of the points around the body. You can see on the image that's there, it's showing the crotch curve running through the body. And you can see at the bottom, there's a red landmark, which is on the hip line that bridges the depth between the two legs. And behind it, we've placed an orange landmark, which illustrates the hip position on the crotch line. And what scanning allows us to do is say, well, you know, traditionally we can get this, using scanning we can get this, but also if we can just enhance scanning a little bit, and if I can get a landmark on that crotch depth that's at the same height as the hip measurement, then I can use that to inform the crotch curve. So we can make quite simple, small adjustments to our practice to start to inform it much more. So again, you know, we can start to make demands about actually it'd be incredibly helpful to have this landmark and this position to be able to generate a depth and change the way we think about pattern practices. And I'll come back to the importance of these points in terms of being able to determine a position in line with the hip circumference on the crotch when we talk about pattern automation in more depth in a couple of slides' time. And this, you know, having more data is useful. I know that often the ISOs and practice guide Sizestream in terms of what you think you need to produce. And I think, you know, you probably agree we've made some demands on the software that are often different from historic practice, because we're thinking, you know, what can you do new with the software? So this is an opportunity maybe to talk about where we can integrate it. So integration is incredibly important, being able to use data from scanning. And this is some of the stuff we've been able to do using Lectra Medaris. So Lectra Medaris Expert has parametric features within it. And that means we can rig a pattern. Okay, so you can see the image here, it's a rigged parametric pattern. The points around the outside of this pattern perimeter, they're there as XY positions based upon calculations, based upon measurements. So we can use software, and this is the benefit of scanning technology, that currently it's a manual approach. We can take scan data, we can identify how it drives the pattern, we can set a pattern up related to the scan data, and then we can input measurements which will change it. So we can set a block up now, because I know as an educator that, you know, when you teach people to draft patterns and you give them 2 or 3 hours to manually draft a pattern, by the time they've drafted it, they probably never want to do pattern making again, right? They don't want to cut patterns. But if you can simplify the process, you can engage them with the theory and the understanding they need. So you can see this block that's there, and it has a chart. I think when I come on, if we just move on to the next slide, actually, if that's okay. Yeah, this shows you more detail. So this is the outline of the bodice. It's connected to a size chart, okay? And you can input measurements in the right-hand side, and this block will adjust to those measurements. So we can use scanning technology to quickly provide us measurements of the body. We can use things like Lectra parametric pattern features to be able to set up a block that responds to the measurements. And then within minutes, we can alter a block from one individual set of measurements to another. And you'll arrive at a block that will be exactly the same as if you drafted it by hand. So in an education setting, we can explore the theory between the size and the shape of a body and the resulting pattern that might then come from that. And what we're finding is a lot of the limitations in pattern cutting methods. We're also discovering limitations in the theory of pattern making and pattern cutting itself. And as well as that, we're finding demands that we have on the software. So very particular things we need. And I don't know, again, if that's something that Sizestream have found with the in-house stuff you've done with pattern generation yourselves, where you're thinking, well, actually, this makes new demands on the software.
Well, for the sake of full disclosure, I'm on the sales and marketing side, not on the pattern making side, but I do know that our what we call our product team, the folks who actually design the made-to-measure garments, have certainly had to stretch the boundaries of both what our scanners were doing previously, and certainly the types of integrations we're doing with 3D design systems. So I think the answer is yes, but I'll let experts weigh in on that, maybe on a follow-up webinar about some of the things we've done in-house at Sizestream that are now that education and that knowledge is maybe being transferred over to customers or relationships that we have within the industry.
All right, well, that's great. I mean, you know, the scanning has really opened up lots of avenues to us that would just be impossible to do without this technology. So I showed you the stuff around the Lectra Medaris and the opportunity to use existing solutions that are there in the industry now. So lots of places use Lectra, lots of places have Medaris. You can run a parametric pattern, you can set it up in Expert, you could run it in Classic, you know, and you can start to do things when you can get volumes of data in. The other thing we've been able to do with body scanning is look at pattern automation using our own in-house software. So this has been a lovely opportunity for us to work with engineers, and they put very different demands on how we think about the technology. So we've developed in-house software, JBlock, which we can draft patterns automatically, directly extracted from the scan data. So we can create a text file that the scanner naturally pushes out through either the scanner itself or through the studio software. And then we can create patterns, you know, in seconds really, for either a number of people or for individuals. And this has really allowed us to start to explore pattern making theory. And again, you can access the software on GitHub, the link's there, and equally the JBlock software. There's a bit of a guide to that on YouTube. You can look at that in your own time. The key thing that we're finding with scanning technology and a lot of this stuff is you can make things so they're very complex and often inaccessible. And for us, largely one of the things we like about using the scanners that we use is they have interfaces we can learn quickly and apply the data in a manner which is quite easy and understandable by current practitioners. We want to move away from a situation where practitioners can't engage with the technology and can't advance their theory. So we're not going for this huge leap in pattern making practices. We're going for these small evolutions and trying to develop robust theories to help us utilize technology and grow our understandings and knowledge. So the JBlock software has been incredibly useful. If we move to the next slide.
Well, before we move on to the next slide or completely, let me just kind of come back to a couple points you made. Because
yes.
For folks who may be on this event today who don't know some of the Sizestream terminology, you mentioned Studio and the scanner software. I'll just briefly say that, you know, we, first and foremost, we don't want to be all things to all people. We want to be a great technology company that delivers a fast and efficient way to capture very accurate body data. We are not in the pattern making software business, right? We're not in the 3D design business. We're very much in the body data acquisition side of the business. And so we've strived to improve our relationships with companies like Lectra, as you mentioned before, and some of the other 3D design companies that are out there in order to make the data more seamlessly integrate with those systems. But I also will touch very briefly on Studio. It became very apparent to us early on in our evolution that the scanner software had a very specific a goal or a very specific mission, and that was to quickly display the image or the data that was just collected about the body excuse me, and that there was a need for a second piece of software for people like yourself, Simeon, to do what we'll call as a more deep interrogation of the data. So to create custom, you know, measurement points, or to take a manual measurement, meaning that not literally pulling out a tape measure, but on the scan form that you saw in front of you, to just be able to quickly draw a line between 2 points, or draw a circumference, or draw what we call a tape measure, where it simulates a tape measure going around the body. So just for clarification's sake, we do have 2 pieces of software that come with the Sizestream system. One is the scanner software. Again, its only mission is to quickly display the more or less the raw data that came out of the system. And then there is a companion product called Studio, which allows you to do that more deep interrogation of the body data before you maybe send it on down the line to a product like Lecture or others. Would you agree with that?
Yeah. And actually, you know, I mean, we're a research-led sort of institute. So, you know, as academics, we need to be able to explore. Studio has been such a lovely opportunity to explore that data in more depth, see what happens if you write something differently, or define your measurement differently, or even manually saying, well, you know, if I could get this measurement from the scanner, and we can start to look at, well, what extra data can we get from it? And being able to write things like, you know, lifting out the depths and widths and things like that from the scan is so important. The example here is two patterns produced in J-block for two different people using one of the trouser drafts we have. And it shows, you know, the difference in leg length. So this is the body driving it. This is measurements taken directly from the Sizestream scanner driving the requirements. Now this and the pattern I'll show you next aren't necessarily ready to go straight into production, but they allow us to start to look at what the theory is and how might it impact on what we need to do. So this next slide is showing you a comparison on the left-hand side, where we've got 5 auto drafts from 5 different people within the population, 5 different women, different sizes. We're using what we've termed the Gill 2 trouser method. And this is looking at how we can use the body to generate it. What you'll notice on the upper 2 patterns there's a pink pattern and an orange pattern. And you can see the crotch curve on the front, which is the pattern on the right-hand side, doesn't quite follow the curve we want. These are people who have a low hip measurement, and the hip bridges the concavity of the crotch region. And because we don't have that Z depth on the crotch curve, we can't drive the curve in the way we'd like to. So the scanner's opened up this possibility of you going, well, you know what, I don't need to use just 1D measurements. I can actually use shape now. And sometimes you can lift the shape out, but also you can go, well, you know, I've got another demand. I want to be able to get points around this crotch curve to drive the curve on the pattern. You can also see how the shape's distributed. The green pattern, you know, is a lot larger. These are standard patterns pushed out with ease allowances within them. Some of the curves could be trued out, and we're not looking in this software to say, here's something which is 100% right, but we have that facility to be able to test and develop theory, which is so important. We couldn't do this without scanning. Another thing that's generated a topic of conversation is about how a leg is centered in the upper part of the body. So where the middle of the knee and the ankle are on each leg relative to the upper section. And that's something we can explore and then think, well, what about the scanner? How can that tell us stuff? And you can get information from scanning that you just couldn't possibly get. So I know you're not a product developer, Jeff, you're gonna have to take my word for it. But you know, when it comes to making patterns, there's information you can get from scanning. I mean, Bai in a 2006 publication was quite clear. You know, you can get lengths, angles, widths, depths, and that volume, that detail of information you can get around the body can really drive new ways of developing pattern making practices. It does require an understanding of historic practices and what we do, the kind of boring part, you know, how does practice evolve? But it really allows us to start to look at things differently and think, what happens if this can be done? And you can use, as I said before, the Lectra-Medaris parametric features. You can really explore it. On the right-hand side, this is an output from J-block as a comparative output. Again, as I say, to explore things, we're looking here at the body rise versus the hip depth. This is kind of like an illustration of the requirement in the crotch curve. You talked about the sort of sag in a pair of pants. Those people that are narrow side to side on that rectangle, the pants might be too big around their body, the trousers, so they might sag. But equally, those people that are really, really wide in depth, those pants might be really tight and quite uncomfortable to wear. So you end up with this opportunity to start to see, well, what's the clustering? And what this also shows is how bodies differ. And they don't just get bigger in circumference as they get taller in height. Sometimes they get bigger in circumference and shorter in height, something that Ashdown in a 1997 research had touched upon as well. And I think this relates again to grading practices and how you might understand and inform them. When you've got population data, you can really start to think about them differently.
Well, that was exactly what was coming to mind for me, Simeon. Again, as a layperson, I look at this and the first thing that comes to mind is does this call into question the practices of grading, knowing that the distribution of volume on that body is going to be different as those people get bigger and smaller. And again, I'm only repeating what I hear in the industry, right? Is that we have such a high returns problem, clothes don't fit. Is this indication of part of that problem?
I think it really allows us to start to understand that bodies don't necessarily fit to this mold of, you know, grading is an imposition on of sort of standardization and rigidity of how the body changes in size and shape. And actually, it's so individual. I mean, one of the things we've learned with the scanner is people are so individual. You know, you can't even group them easily. There's so little consistency within a population in terms of when you start to look at, you can find somebody normally distributed on one measurement and not normally distributed on another. So it really allows us to start to think about this. I mean, having visual outputs from the scanner and exploring data in a different way is such an exciting prospect that, again, only scanning technology really allows us to do that.
Well, you mentioned population, and I wonder, it'd be maybe great for you to expand upon the idea that you need to scan some population. How many people do you need to scan in order to produce the kind of analysis that you're talking about?
Okay, so, I mean, you can see on the left-hand side, there's only 5 patterns there, but that's quite informative for the requirements. It tells me how we might want to change the data that drives product, but it also allows me to understand the bodies. And that's just from 5 scans. Now, it's from a larger population. On the right-hand side, it's about 40, 50 scans that allow us to do that. Obviously, the more data you have, the more opportunity there is to start to say, oh, look at the similarities here, or look at the clustering there. But from a usefulness of scan technology, 1 scan is useful, you know, in terms of what it can tell you. And really, if you can get a scan of a fit model and compare that to a population, then you can start to engage with products differently, because your fit model, they set the parameters for how everyone in the, you know, your wearer base, your customer base is going to experience fit. I mean, I'm not a great believer in ready to wear. I much prefer the idea of bespoke clothing, but I am under no illusion we're going to just fall into bespoke clothing overnight, because our practices are so geared to ready to wear and large populations, it's going to be hard to change. But even small volumes of scan data can really help people understand, and especially if it's targeted. If you can get small populations of scan data for a very specific consumer base, you can really start to understand what that means. So it's not just large volumes of data. It's lovely for typical statistical analysis, but even small amounts of very heavily targeted data can really tell you important things about the body.
Well, that certainly brings up a follow-up question, if you don't mind, which is, so you mentioned targeted scan data. What do you say to the folks on this webinar today who are considering purchasing scan data from surveys or from, databases, if you will, where they have scanned people? How does that compare to scanning your fit model and scanning a specific set of people that you're targeting? I guess I'll leave it there, and maybe you understand my question, hopefully.
Yeah, I do. You need data you can understand and you can use, okay? If we're just going to keep plodding through the same approaches that we've developed over the last 100 years towards clothing development, then you know what, buy unknown population data. But when you buy population data, you're often just buying measurements. And when you're buying measurements, you don't even know. I'll give you a really clear example of where difficulties can be run into. In the Size UK data that was captured from body scanning, the hip was defined, actually the waist was defined differently from the Size USA data. So a Size USA waist compared to a Size UK waist will be different because they're defined differently. And that runs true for lots of things. There is lots of times when data is defined slightly differently, extracted, pushed out with the same name from a different scanning system, and it's theoretically believed to be comparable. You need control over it. So, collecting data and having data you yourself understand is so important. Without rigid standardization of how bodies are analyzed, it's important to have more control over the data you collect. So buying population data, that's lovely if people want to continue down the route of standard sizing. But as soon as you want to move away from it or understand it, you need data you've collected yourselves.
So it sounds like you're an advocate for get a scanner and scan your customers.
Absolutely, yeah. I mean, just get a scanner and educate your company, about things rather than talking, people will make broad generalizations about populations. Get a scanner and test it and see how that rides out. See what it really means. And it brings us, I suppose, nicely onto this slide here, where I was going to talk about how the scanner can help you understand the body differently. So I've said that, a facility to engage with the body and understand its size, shape, and proportions. And we've been playing around with, and I say playing around, we don't have a defined output from it, but it's something that's generated from our engagement with people being scanned over the last 15 years. And we've been looking at ratios. So there's a size independent comparison tool, and it leads to really interesting conversations. On the right-hand side, you can see a comparison between the circumference of the chest and the circumference of the waist. A very typical thing relates to drop values in the industry. And we can look at it and say, well, the average relationship is the bust is 122% of the waist circumference we're getting. But we can also see what the range is. You can see a histogram. This is just 500 scans, but it's enough to start to get an understanding of what that means for a population and where the parameters might be. And it helps us to think about waist shaping as well. On the right-hand side, which is more interesting for me, is this sort of torso length to leg length ratio. So this helps us to understand how people might engage with clothing and their body might relate to clothing. So when you scan lots of people, they come in and they'll say things like, we've got short legs. And you're like, well, that's lovely. And they probably learned that through how they've been judged or how they found clothing fit. And we can take scan data and take the torso length and the leg length and work out the relationship. So we know that on average, the female population we've scanned, their torso length is 89% of their leg length. So when people come in and say, I've got short legs, well, if they're on the right-hand side of this histogram and they've got a one-to-one relationship between their leg length and torso length, then you know what? They probably do have short legs. And then we can talk to them about what that means in terms of clothing. So scanning can open up these discussions with a consumer base, with a population that you just couldn't have using anything else, because you can get data so quickly and in such depth. You can play and have a look at what ratios really mean, you know, and when people have long legs, as they must do, you know, there'll be some outliers in this data, but there are people whose, you know, torso length is 80% of their leg length. These are people with long legs in a population. What does that mean for them? How do they buy clothing? Do they just accept that trousers are all too short? What does a company do with that data? How can it really think about what that means for its customer base? And ratios are there in pattern drafting. I don't know if this is among the more unusual things that you see customers trying to do with the Sizestream interface.
No, I think it's pretty typical.
Oh, that's good. It's
well,
nice
for those teams that are focused on technical design. Clearly, we have customers who are more in the customer-facing arena with scanning, but we have, I would say, a decent customer base now, where the technical design teams have bought their own scanner and are scanning fit models, wear testers, you know, a whole range of people in order to get that insights into, well, the feedback loop into the technical design process, right?
Okay, yeah. Exactly. I think it's really important. If we move to the next slide, I think I remember. Okay, so it wouldn't be a discussion around body scanning if we didn't talk about precision, accuracy, and error. So you can see at the top here, accuracy, repeatedly taking the same measurements, appropriateness, taking the right measurements, and precision, taking the same measurements within given tolerances. So what we found with the scanning technology is using repeat scanning and systems of data processing, we can meet and beat precision requirements, even the best manual studies. And the best manual studies are usually pointed out, the ANSHA studies. So, you know, scanning gives us the opportunity to get really good precision. Precision often better than you would get in manual measurement. Getting good data as well requires robust procedures. So this is not just the scans, what you collect alongside, you know, getting the weight, getting the height, getting the age, getting other information about the person that you're scanning as well. That can really make a robust data set. It's not enough just to have the scan if you're going to do things with it in real depth. You want to think about what you collect alongside. And I think that's where there's a need for the sort of community to step in and say, well, this is what we collected alongside the scans. Your point 3 there is insufficient discussion of shortcomings of manual measurement. And this is a problem, right? I'm under no illusion that the types of things that I want to do with body scanning and my team want to do with scanning just will not happen with manual measurements, because it takes too long. It takes, you know, a lot of time to measure somebody. You're, you know, setting up the equipment, getting them to stand still. Scanning tends to get bogged down in this discussion around, well, is it accurate? But really we're talking about, is it precise? Can it take the same measurements within given tolerances? And when you look at repeat scans, you find it can. And, you know, no one talks about, say, the ANSHA survey, where they measured people and they came up with the tolerances. What they didn't tell you is for those tolerances, they determined them, they trained the measurers. At the start of the day, they made sure people were within tolerance. And then they set them off and they measured people. And they didn't do spot checks. They didn't check them to see how repeatable the measurements were during the process of collecting the data. They just said you were good at the start and you're good going forward. So there needs to be a more robust understanding of what we're really talking about here. And I think we've gone a little way down some of the route that Sizestream have taken, where we're saying, well, it is precise, but not only is it precise, let's just show you how we can use it. And we're looking at what you can get by taking the data into product development with things like the automated block development as well. And scanning just gives you that so much more data, such a richer picture to be able to inform product development.
And I will put an exclamation point at the end of that by saying, first and foremost, this was not a paid endorsement by Simeon Gill of the University of Manchester. It's just his own experiences in using the Sizestream product. And I will go on to say that, this is probably the most common question and discussion point that comes up with folks who are trying scanners for the first time is it accurate? And I'm really glad that you've offered up at least your personal experiences and your professional experiences in working with Sizestream products, is that we fundamentally believe and we fundamentally have data to prove that scanner measurements are simply more precise and repeatable than hand measuring. And so we sometimes wince at the question. We have kind of this knee-jerk reaction when people say, is the scanner accurate to within, say, 5 millimeters of our existing measurements? And the answer is usually almost always no.
But then equally, are your manual measurements within 5 millimeters of each other?
Well, exactly, and that's the rub.
A different one.
Yeah, that's the rub. Yeah.
What scanning does is like saying, we're just bringing in the same person to measure every time, right? And we know from all the studies that having the same person landmarking and measuring is more consistent. There's no possible way that in industry we have the same person landmarking and measuring all the time, but the scanners like that. The scanners just say, no, it's the same person every time. So, it undoes some of those shortcomings as well.
Yeah, and just to clarify my statement, just in case anybody was confused, is that when we almost always say no, it's not that we don't believe the scanner is accurate enough to produce millimeter level accuracy. It's that when they're compared to the hand measurements, which in themselves are typically more variable than the scanner, we end up with what, I'll use your term here, a higher error rate. And for anyone on the call today who's interested, we have a white paper that's been produced. And Simeon, you may be familiar with the study we did in conjunction with IEEE Standards Group last year, but we took, I believe it was 4 measurers. They weren't answer measurers, but they were industry professionals who've been working on measuring the human body for years and years and years. And the goal of the study was to really compare scanner measurements to hand measurements by professionals, not retail associates, but by professionals. And the outcome of that study was quite eye-opening for us. I mean, not that we didn't believe we would do well, but that the error rates associated with hand measuring when comparing against multiple people was significantly higher than obviously one person measuring, and even more significant when you compare it to a scanner. I don't mean a scanner, obviously, it was a Sizestream scanner, so we don't have information to share about other people's scanners. We have information to share about our own. But I think it's worth making this point because it is the most common question that comes up is it accurate enough? And the answer we will give you is yes, but you have to be willing to accept the baseline is another scan and not hand measuring.
Oh, absolutely. And the benefits of scanning are so much more than the information we would get from manual measurement. If we move to the next slide, I think, yeah, so one of the things we do with the scanning is we have open sessions at the university. We're, as a publicly funded education institution, it's partly what we're supposed to give back as well. But we run sessions for industry to engage with body scanning. We can help people come and understand what it is, how it works, and look at possible research opportunities like pattern automation. People can book into scan sessions. We've one tomorrow. I haven't done the rest of them for the year. But what this does, having these open scan sessions, it helps us to understand consumer needs from body scanning and support those wishing to use the technology to access scan data. It lets us train up a skilled team. So we have people now in-house who will go into industry who have learned about scanning technology and have the foundations to start to think, well, what can it do? How does it work? How do I understand it? And they can generate their approaches toward processing the data and analysis of the data as well, which is crucial. If you just move to the next slide as well. So this is my summary really of where we are. I mean, you know, I work in an education institution, right? The cost of things is important because it can't be prohibitive. So when we use scanning technology, any of this solution has got to be affordable, accessible, able to integrate and responsive to needs as skills change and develop. So, you know, we need to be able to buy scanning technology that we can get in at a price point means that people think it's a suitable investment. It's got to be accessible, which means, you know, that people have got to be able to learn how to use it quite quickly and understand what comes out of it as well, and then able to integrate. So we sort of touched upon that with the JBlock stuff, but also with Lectra's parametric pattern features. We can use this data in a way that can start to integrate with other systems as well. You know, we can take scans out from the software as well and pull them into 3D fitting. Now, it isn't to say there aren't issues with it, but the more people we can inform about the issues, the more likelihood is that the industry itself, that people generating these solutions can start to focus on resolving those problems. And then responsive to needs of skills change and develop. So when we started using scanning technology, it's like, can it produce what we've historically used to get? And now we're like, you know what, we need this actual information from it. We didn't need it before, but we recognize we need it now, and it can really change our practice. And I think, you know, we sort of burn the ears of Sizestream a little bit, making our demands heard, and sometimes they're only coming from us, you know, but I think it's important, that responsive, integrated nature of being able to influence the people developing the solutions, like we're trying to do with Sizestream. And, you know, broadly, there are some great solutions available, but it's imperative we find ways to support innovation, considerate of past practices, mindful of new opportunities. We need to know, what do people currently do? How have they approached things? And then how could we do things differently? We don't want to be wedded to bad practices. And if I just touch upon an example of where that might be, right? If you manually measure people, if you were to manually measure the largest circumference of the calf, you might take a metal tape measure and learn how to manipulate that around the calf region to find the largest circumference of the calf in the lower leg, right? And the scanner just goes, so you want the small region, it's there. The scanning has no difficulty finding the largest and smallest dimensions. It kind of frees us a little bit, right? We're not tied into, well, we've got to find it relative to this landmark, which is about creating population data which is theoretically comparable. Scanning allows us to say, where are you small and where are you big? And how do you change over this region? And it can really change how we understand stuff. So from our perspective, if I want to make trousers, I don't just want the seat measurement or call the seat measurement the hip measurement, right? I want two measurements. I want the largest lower body circumference, lower than the seat, which should be the hip because of the, definitely on a female, on a woman, because of the way the legs are shaped and the thigh fat deposition and things like that. But I need the seat measurement as well. So I can start to say, well, you can size off limited data if you want, but I can generate practices of creating well-fitting garments that respond to more of the body. I can use the hip, I can use the seat, I can use the abdomen, I can even divide regions up. And it creates new ways of understanding how the body drives product. I mean, fundamentally, just to wrap up, one of the things with this technology, it provides an opportunity to collaborate. We need to collaborate more. It's really important. There is two-way communication. We need to share more, and we absolutely need to use the technology to inspire each other. One of the things we've done to help our students understand is started these guides to using the studio software. You can access that at the link there, and it's just about getting people in. The more people can use it, the more people can really benefit from it. And I'm sure I've probably missed a lot of things that were on my notes that I intended to say, but hopefully I've made some of the points about how scanning has really freed us from some of the constraints of manual processes and allowed us to be really innovative in how we tackle challenges in making clothing.
Well, I certainly think it was informative. And the good news is we have some questions that may actually cause you to think about some of those notes you wanted to cover. So the first question is on JBlock, what patterns base are available? So I think the question was what pattern bases are available, but maybe you understand the question better than I do.
Yeah, as we aren't necessarily using it to create typical methods that might be there. At the moment, we've got two trousered methods, which are kind of new approaches towards it. They allow us to deal with how the body might drive the pattern. We've one or two bodice blocks, some of them from existing methods that you would typically find in books that people might follow. And this is the real problem. People, you know, there are two things. We've got a couple of patterns in there. We've got a bodice, a sweatshirt, some trousers. They're developing methods that allow people to explore the software. The other thing people are often not aware of is there's a variety of different methods that are used to develop pattern blocks. If you're learning to develop pattern blocks in the US, you might be using Helen Joseph Armstrong's methods. But if you're learning to develop pattern blocks in the UK, you'll be using Aldrich's methods. They will require different measurements. They will result in different blocks. So what we've done to generate some of our new pattern making methods is, or pattern drafting methods, is look at what happens in existing methods and then how might we evolve them. So we don't have lots of blocks on there because it's an explorative tool. We're not saying to somebody, you follow this method and you'll get a pattern out of it. We're saying, this is a great opportunity to explore how a body drives a pattern and start to generate theory. I am under no illusion that we're not at the start of this, okay? You see people saying, oh, here, we automated this pattern on the system. And then you say, well, that's lovely. You automated the pattern. How did you divide the side seam? How did you decide on the arc division? How did you take account of these other things that are so important to the pattern? And those questions are never answered. And so we're trying to look at those things as well. How can we answer those questions?
Great. And so kind of I think it's a quick follow on to that one, Simeon, is when you mentioned on slide 13, you used the word auto draft. And that was the slide you had up with the different pattern or trouser patterns. And then you had the kind of distribution of relationships to the, I think the hip and the length.
Mm-hmm.
So the question was, does Sizestream have that capability or Electra? And maybe you can answer the question because you made that slide.
In terms of, Sizestream provides the data. The capability is built into the software. So Sizestream means that we can start to, if you were to draft a pattern following a method that's generally in the books, right? They'll define your knee level as maybe halfway from crotch to floor minus 5 centimeters. Right, but the scanner, you just go, well, there's the knee level, right? It's easy to strip out, and so that can drive it directly. So we're looking at how the body relates to the pattern, and it drives it directly. The facility, the Sizestream software, the scanner itself provides that opportunity to have the body and perform the innovative analysis on it, and either JBlock or Lectra allow us to apply that data to automate the pattern. So it's free drafted. You know, there's a bit of something quite important that the industry really contends with. People who draft patterns, and then there are people that grade patterns, but it's the same thing, right? All a pattern is a series of X, Y Cartesian coordinates in a 2D surface, and you position them in drafting and you move them in grading. And we're just positioning them. We're starting from the draft process. I'm not looking to grade or modify using made-to-measure systems of repositioning X and Y. I'm positioning X and Y based on the body uniquely for every time we draft.
Well, thank you for that detailed answer. And just to make sure it was clear, Sizestream does not have any auto drafting capability. We are specifically and strictly about the acquisition of body data.
We can sell you an interface we're developing.
Okay. We'll put that person in touch with you. And so here's a question that I can actually answer. The question was, do you have to add physical bony land markers when scanning in Sizestream scanners, or are the body markers and the presentation applied afterwards? So the Sizestream software automatically detects, I believe we're up to about 300 landmarks. And those landmarks are, Simeon, you probably can speak to them in terms of the definitions better than I can, but we have a very detailed landmark definition list that we'd be happy to provide anybody who's interested. And those are the types of things that I believe would have been manually applied, like shoulder points, front of neck, back of neck, most bust front, the most pronounced area of the bust. But there's 300 of them, and those are all automatically applied on every scan. And I'll follow that up by saying from those 300 landmarks, we also automatically generate roughly 240 measurements. And so we're often asked, well, why so many measurements? I don't need that many measurements. Well, we have 7 different pant waist measurements, if you will, or waist measurements, excuse me. We have a pant waist, a tilted pant waist, a high waist, a low waist, a mid waist, a narrow waist. So there are lots of different waist measurements because ultimately our customer base is quite diverse. And not everyone, wanted the same exact waist measurement. So we simply produced and continue to add to the list of measurements as new learnings come into our team about what is required in the market. So just to be precise, we automatically apply the landmarks and we automatically take the measurements.
There's a sort of fixation that people have with manual measurement techniques where, you can find landmarks and palpate them, but it goes back to the point I made around the calf. The scanner deals with the body differently, right? I wouldn't pre-landmark up because I want the benefits of automation and I don't want the time spent landmarking somebody at the start because it takes time to do and it requires skills to have that. But if we're looking at, for instance, say you want to measure the ankle and you find in the lateral or medial malleolus from the ankle, right? They're easy to palpate. The scanner might struggle because the scanner's dealing with surface geometry. We're dealing with the surface geography when we're manually palpating somebody. But if you want to find the narrowest part of the leg, which is above the ankle, the scanner finds that for you. We shouldn't be so rigidly wedded to this idea that manual landmarking is important. What's important is we get data which informs product, not necessarily that we get data which is tied to our historic practices. Another example of where that might be a generally known soft tissue landmark, the nipple, for instance, okay? They use the nipple and say, this is the landmark that we're going to use to define the bust point. But the scanner will say, well, actually, there's a flat region on the front of a female bust or a female's bust when they're wearing a bra. And this flat region, that's where you want to point at the greatest forward projection, right? If you use the nipple, it could be slightly misleading. So that's an example of where landmarking itself might lead to issues that the scanner just says, well, ignore that. What we're concerned with is where's this mass? Where should suppression point to shape effectively? And scanning can do that. It actually allows us to overcome some of the difficulties we might be doing at a fitting stage where we're contending with the topology of an individual body.
Well, since you brought up bust, there was another question regarding how do you control the suspension of the bust when scanning to make sure the protocol is repeatable and consistent? I'll have an answer. Maybe your answer is different than mine. We recommend that females wear a properly supportive bra, but not a padded bra. So I believe a lot of companies refer to that as a calibration bra. But the key is that it's not overly padded and it doesn't overly change the volume and shape of, well, it didn't change the volume, it changed the shape of the bust. I don't know if you have a more exacting answer, Simeon, you'd like to offer?
Well, what I would say is, we're looking to make garments that fit the bodies that people present within the shop. So, if someone wears a padded bra and we want to make a dress for them, then we're measuring over the padded bra because we're measuring them in what they wear. So we just ask people to come to scanning sessions in ordinary underwear, the underwear they'd wear every day, because we can measure them in something which controls for things, and that's lovely. And then notionally, we can look at how a population appears realistically, but if we're then making clothing for those people and the garments they wear hold their body differently, then you know what, we need that data because that's what matters. If we make for them in garments which hold them differently to their everyday clothing or measure for them in those, we're going to be misleading what we really need to drive product. So we just ask for people to come in what they wear sort of every day, as it were.
Okay. So there was a question regarding the portability of the scanner, and we can share with anybody who's interested the brand new, we'll call it transportable version of our scanner, which is essentially a rolling case where the scanner can be packed down into what looks kind of like a stage, like you might see at a concert. We pack the scanner down into a single case. It can be rolled easily on and off a truck or a lorry, as you would say in the UK, Simeon. It's not overly light, but it is portable in the sense that you can easily roll it to a location. The scanner itself takes approximately 45 minutes to an hour to set up, and roughly about the same time to tear down. Actually, that time decreases as you do it with frequency, so you can get it down substantially less than 45 minutes. But as a new user of the scanner, it's not a very difficult thing to set up and tear down. It travels well. We actually just took one on a tour of a state here, Florida in the United States, in the back of an RV. It bounced around the road just fine, scanned people repeatedly and reliably throughout the week. So it is easy for these scanners to be battle tested on the road and be able to produce reliable results. And then the last question that we got was, will the session be available in replay mode? Absolutely. It'll be available on demand after Ryan on our marketing team publishes that out. There was one more question that just came in. I'm just reviewing it quick. So this is a bit of a long question. I think I'll respond to this one in email because I need to digest what it's saying. So maybe for the person who just put this in, let me answer this one separately in an email because it looks like there's a lot to unpack here. So Simeon, I want to say thank you very much for what I believe, and based on the comments we're getting, was a very informative session. Obviously a pretty deep dive in the pattern making and the technical design side of garments in conjunction with 3D body scanning. Anything else you want to offer before we head off to our wrap?
Yeah, I'm really grateful to have had the opportunity to talk about a lot of the research we've been doing and been able to do. You know, I suppose, you know, it'd be meaningful to say we're always looking to collaborate with people. We're happy to have conversations with people about our experiences of using scanning technology. We've created quite a few things to share with people in the community so that people can benefit from, you know, we had a protocol for what you collect outside of when you just collect the scans as well. So, you know, what type of information should you think about and how should you collect it, which I think is published somewhere, and I'm happy to share stuff if people contact us. I mean, we're really keen not just to help the people that we teach in the university, but to help anybody really benefit from what scanning technology offers. I think it's a really great opportunity for a step change in how we think about designing products for people. And I really want to be able to do bespoke stuff because I think that can open up pattern making, pattern cutting, as it were, and design and the creative side to people in a way that is much harder to do if we just stick rigidly to traditional methods. So thank you very much.
You're welcome. Thank you for giving us so much time. But before everybody drops off, we got a couple of announcements to share with you. If we'll move on to the next slide there. So if you are attending Pi Apparel in Italy this year, I believe it's about a month away now, we'll be exhibiting there. In fact, we'll be putting on display something that's rather exciting that we just announced yesterday. So please check us out at Pi Apparel. And as a follow-up to that last comment about what we announced yesterday, we will be doing a webinar just again by the end of the month, so just a few weeks away, on what we have called Sizestream at Home. It was announced yesterday, and Dr. David Bruner, our CTO here at Sizestream, will be going into a more in-depth look at being able to scan subjects with a mobile device. So I know we've been 18 months in development on this one. We just launched it yesterday. It's live on Kickstarter, so you can check it out there. You can also check it out on social media and our website. But it's a pretty exciting announcement for us, and we will be doing live scanning at the Pi Apparel event, in addition to doing some deeper dives on what this technology is unlocking for the industry later on this month at a webinar with David Bruner. So I want to thank everyone for hanging out for the entire hour. Hopefully you got some great information from Simeon on how body scanning is influencing and changing the way people think about product design. And we look forward to the next event, if you'll show up and give us another hour of your time on the 25th and talk to you about some exciting new technology that's just been announced by Sizestream. So thanks everyone for your attendance. Have a great day and look forward to seeing you next time.